Okay, let's keep going. So let's solve this inequality. So again, I'll get my zeros, which are -1, -4, and +5. So when I put them on the number line, I just want to make sure they're in order. So that would be -4s first, then -1, and then +5. Okay, so let's choose some test numbers. Anything smaller than -4, so -5. Anything in between -4 and -1, so let's do -3. And then in between -1 and +5, we'll do the 0. And then anything that's bigger than 5, so like 6. Okay, so plug them into the original and see if it comes out as a negative. So if I plug in -5, I have a negative times a negative times a negative. That's a negative. If I plugged it into the negative, or plug the -3 in there, I get a negative times a positive times a negative, so that's a positive. Plug in the 0, positive, positive, negative, so negative. And then if I plug in the 6, positive, 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 so that's positive. So I want to go back and look at this inequality again, and it's less than or equal to 0. So I want those negative signs. So the negative signs are in 2 different intervals. They're from -4 on down. So that'd be -infinity to -4. And then I've got another one sitting in between -1 and 5. Just like that. And I use the brackets again because it's got the equal bar. Okay, let's try some other ones. All right, so now we have a rational inequality. So again, just get your zeros. And it's whatever makes the top 0 and also what makes the denominator 0. So -1 from the top, +1 from underneath. And same thing, like you don't care if it's rational or a polynomial, just get your zeros, set up the number line, and get your test numbers. So anything less than -1, let's go with -2. Anything in between -1 and 1, 0. Anything bigger than 1, let's go with 2. And just plug them in to the original function. So you get a negative over a negative, which is a positive. Plug in the 0, so positive over a negative, which is a minus. Plug in the 2, positive over positive, it's a positive. So my inequality, though, is I want them greater than 0, so I want the plus signs. So that one and that one. So the plus signs, they occurred from -1 down. So -infinity to -1. And then the other plus sign was from 1 and higher. So 1 to infinity. And I'm using parentheses because there's no equal bar. Okay, part D, my zeros, 3, -2, and +1. So let's put them in order. So -2, 1, and 3. Get some test numbers. So like -3, 0, 2, and just for fun, let's do 85. just because we can. Okay, plug in the -3, and you get a negative, and a negative, and a negative, so that's a minus. Plug in the 0, negative, positive, negative, so positive. Plug in the 2, negative, positive, positive, so minus. And plug in the 85, positive, 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 and it's a plus. Now, on all the examples that we did, the signs alternated. It does not always alternate, so you do have to test them, because sometimes you might get a function where it goes like plus plus minus, or minus minus plus, something like that. So you need to check on them, to see what the signs are. Don't assume that if the first one's a negative, it's just going to alternate all the way down, because some of them don't. These did, but that's just because those are the ones I picked. Okay, so your inequality here says, hey, we want the minus signs. So the minus signs are from -2 on down. So -infinity to -2. And I've got the other ones sitting from 1 to 3. Okay, now some of you are going, whoa, wait, he just used a parenthesis on the 1. And I did. And that was because the 1, that 0, it's coming from the denominator. So you can never include a number that makes the denominator 0. So if the 0 is coming from the denominator and that's in the interval, you're always going to put a parenthesis on it, even if the inequality has an equal bar. So just be careful and aware of that little fact. Okay, so let's take a break right here, and then we'll pick up with example 3.